So the answer is many of the properties are desirable. The second property is desirable. So the first property is not desirable, that if the hash function outputs a unique number for every keyword, well, then the range for the hash function would be very large. We'd need a huge amount of memory to store the hash table, and the number of buckets would be the same as the number of keywords. That's not going to work very well. What we want is the number of buckets to be b, so that means that the output of the hash function should be in the range between 0 and b minus 1. That will find the element of the list that corresponds to that bucket. So we do want the second property. The third and the fourth properties say that we want the number of keywords in each bucket to be approximately the same. So if they're k keywords and we're fitting them into b buckets, if we want the buckets to be approximately the same size, then each bucket should have approximately k divided by b keywords. So both the third and the fourth property are true. The final property says that we should have more keywords in bucket 0 than in bucket 1. There's no reason that we would prefer that. So you might think it would be better to have more keywords at the beginning than later on. That's not the case with a hash table. Remember, what our hash function does is tells us right away which bucket to go through. We don't have to look through the earlier buckets. This is different from the list index that we started with, where the first one is the fastest one to find and the last one requires going through all the elements. For the hash table, that's not the case. There's no reason to prefer having more entries in bucket 0 to bucket 1. What we really want is to try to have all the buckets have approximately the same number of keywords.